we are being given a fraction which is 1 plus 11x minus 6x squared all over, and then in brackets x minus 3 times 1 minus 2x. And we're told it's identical, as denoted by this identity sign here, to a plus b over x minus 3 plus c over 1 minus 2x. We have been asked in part A to find the values of the constants a, b and c for 4 marks. Okay, I'm going to highlight that a, b and c are constants. Okay, and the way I'm going to go about solving this question is I'm going to try and manipulate the right hand side so the two denominators match. Okay, so just as a recap, if you have, say, 3 fractions, so you have a over b plus c over d plus e over f. Okay, what you need to do is you need to do ADF plus CBF plus EBF, and then you can divide it, or you do all over BDF, okay? Because then they'll have a common denominator of BDF, sorry, and you can add them. So that's sort of what we're going to try and accomplish with our partial fraction form here, okay? So what I'm going to do is I'm going to start by writing 1 plus 11x minus 6x squared over x minus 3 times 1 minus 2x equals, is identical to. Okay, so the first thing to get x minus 3, 1 minus 2x for a is we need to multiply the numerator and denominator both by x minus 3 times 1 minus 2x, okay? So we end up with a x minus 3, 1 minus 2x. To get b in the correct form, it's already got an x minus 3 in the denominator, so all we need to do is multiply by 1 minus 2x, so b 1 minus 2x, and then same thing with c, it's already got 1 minus 2x, so all we need to do is multiply by x minus 3, okay? All of this will then be divided by x minus 3, 1 minus 2x. Now, at this point, we're going to use another rule, which says if you have a over b is identical, is equal to c over b, what this means is a equals c, okay? So what we're going to say is 1 plus 11x minus 6x squared equals a x minus 3, 1 minus 2x, plus b 1 minus 2x, plus c x minus 3. Okay, so now to find each of our constants, what we need to do is we need to eliminate the other terms. Okay, so say I want to find what the value of b is, I need to eliminate a and c, and the way we're going to do that is we're going to be looking at the x terms in each of them. Okay, so to find a is going to be a bit harder because we've got both x minus 3 and 1 minus 2x, so we'll come back and we'll do that at the end. But to do b is going to be relatively straightforward, so we can say to find b, okay, we need a and c, the x terms making up a and c to be 0, okay? So we can say x minus 3 equals 0 because x minus 3 is the only one which appears in both of them, okay? This means that x equals 3, alright? Now I'm going to plug in x equals 3 into this side and into this side, okay? And I'm going to solve it. So it's going to be 1 plus 11 times 3 minus 6 times 3 squared equals, so a times 3 minus 3 is going to be a times 0 times 1 minus 2 times 3, so that's just going to be 0, okay, plus b, 1 minus 2 times 3 is 6, so it's going to be 1 minus 6, 1 minus 6 is minus 5, and then c is going to be c times 3 minus 3, and 3 minus 3 is 0, so it's just going to be 0, so we can leave that, okay? If you were to put this into your calculator, you would end up with 1 plus 33 minus 54, okay, which is minus 20, so we have minus 20 equals minus 5b, and what this means is b equals 4. The next step is to find c, and we're going to just use the same principle here, so say to find c. Now we need the term which makes b and a 0, and that's 1 minus 2x. So we're going to say 1 minus 2x equals 0. So we get 2x equals 1, and therefore x equals 0.5. again, I'm going to plug x equals 0.5 into our left hand and our right hand side, and we're going to solve for c. So we're going to have 1 plus 11 times 0.5 minus 6 times 0.5 squared equals, so a is going to be a times x minus 3 times 0, so it's just going to be 0, plus b, so b times 0, so that's going to be 0, and then c, so 0.5, sorry, minus 3 is minus 2.5, so it's minus 2.5c, okay? Now, 1 plus 11 times 0.5 minus 6 times 0.5 squared, if you put that into your calculator, will get you 5, okay? So this will be 5 equals minus 2.5c, and this means c equals minus 2. Alright? Now, before we find a, I'm just going to take a step back. I'm just going to rewrite what we know so far. So we know that 1 plus 11x minus 6x squared equals a, x minus 3, 1 minus 2x, plus b, now we said b is 4, so it's going to be plus 4 times 1 minus 2x, and then plus c, but c is minus 2, so it's going to be minus x minus 3, okay? Now, to find a, we can't really substitute anything to make the rest of the terms 0, because anything we plug in will also make a times 0, so it will remove it. So what I'm going to do is I'm just going to let x equal 0, and we're going to solve for a in that way. Okay, so we're just going to say x equals 0. This means we have 1 plus 11 times 0 minus 6 times 0 equals a, so 0 minus 3, and then so that's minus 3, 1 minus 2 times 0, so that's going to be 1, so it's going to be a times minus 3 times 1, so it's going to be minus 3a. 1 minus 2x, so it's going to be 1 minus 0, which is going to be 1, which is going to be plus 4, and then minus 2 times minus 3 is 6. Okay, so we end up with 1 equals minus 3a plus 10, minus 3a equals minus 9, and a equals 3. Okay, final step is just to write it all nicely to the examiner. Okay, so what I'm going to say is 1 plus 11x minus 6x squared over x minus 3 and 1 minus 2x is identical to 3 plus 4, so b over x minus 3, and then plus c, but c is minus 2, so it's going to be minus 2 over 1 minus 2x. Okay, this isn't necessarily required, because we've only been asked to find a, b, and c, but you know, it's nice to write it in the final form that was given to us in the question. So this question is worth 4 marks. Your first mark comes from knowing you need to manipulate the right hand side to get it into this form here. Okay, so to get 1 plus 11x minus 6x squared equals a x minus 3 times 1 minus 2x plus b times 1 minus 2x plus c x minus 3. Okay, your second mark comes from getting that a equals 3, okay? So you could have done this in a magnitude of ways, but if you've shown somewhere that a equals 3, you get your second mark. If you've shown somewhere that there is an attempt to find either b or c, and you get b equals 4 or c equals minus 2, you get your third mark. Now we've gotten b equals 4, so we can secure our third mark. And then your final mark comes from as well solving c and getting the correct final answer as we have here. We have been told fx equals 1 plus 11x minus 6x squared over x minus 3, 1 minus 2x, where x is greater than 3. We have been told to prove that fx is a decreasing function for 3 marks. Okay, so I'm first going to highlight the keyword, which is prove, and I'm going to highlight that we need to show that fx is a decreasing function. Okay, and the reason this is important is because a decreasing function, effectively what it means is, it means we need to show that the first derivative is less than 0 for all x in our domain. Okay, so the first step is actually to differentiate fx. But before we do that, what I'm going to do is I'm going to rewrite fx in a nicer form to work with. So I'm going to say fx equals 3 plus 4 times x minus 3 to the power of minus 1 minus 2 times 1 minus 2x to the power of minus 1. Okay? Now, what we can say is the derivative of fx equals derivative of 3 with respect to x is 0. Now, 4 times x minus 3 to the power of minus 1. If you were to take a u substitution, say u equals x minus 3, du by dx equals 1, so that doesn't change. The minus 1 comes down as a power, so it's going to be minus 4, okay, because we've got the 1 from the du by dx, so that doesn't change. X minus 3 to the minus 2. Now, minus, so this one's going to be a bit more tricky, because if you do u equals 1 minus 2x, what you will end up with is du by dx equals minus 2. So you will end up with this minus 2 times the minus 2 which comes from your du by dx to get 4. So it would be 4 times 1 minus 2x to the minus 1. The minus 1 comes down to make it minus 4. And then it's 1 minus 2x to the minus 2. Okay? Minus 4 times 1 to the minus 2x to the power of minus 2. Okay? So we're going to just rewrite it in a much nicer form. So what I'm going to say is, first actually, we're going to use the rule that a to the minus n equals 1 over a to the n. And I'm going to rewrite all of these in terms of fraction form. Okay, so we're going to say this is minus 4 over x minus 3 squared. Okay, now what I'm going to do here is I'm going to write plus and then minus 4 over 1 minus 2x to the minus 2. Okay, not to the minus 2, sorry, just to the power of 2. And you're going to see in a second why I'm doing this. Okay, now we know that we are only considering this from when x is greater than 3. Okay, so what we need to say is x minus 3 squared. So when x is greater than 3, okay, say 3, when you put in 3, you have 3 minus 3, which is 0, so 0 squared is 0, okay? But whenever it's greater than that, whatever the difference is, because we're squaring it, it's always going to be greater than 0, okay? So what we need to say is, this is greater than 0 for all x is greater than 3, okay? The same thing applies for 1 minus 2x all squared, okay? Because whatever value you put in, regardless of the result of 1 minus 2x, it will be squared, so it will always be positive, okay? So this is going to be positive for all x is greater than 3, okay? Now, if we look here, what this means is 4 over x minus 3 squared, so ignore the minus for now, the 4 over x minus 3 squared will be positive, but this negative will make it negative, okay? So what we can say is that therefore minus 4 over x minus 3 squared is less than 0, and minus 4 over 1 minus 2x all squared is less than 0. Because in both cases, we're taking 4, which is a positive number, we're dividing it by a positive number, which means it's positive, and we're multiplying it by minus 1, which makes it negative. Okay? So what we need to say then is, we have shown that minus 4 over x minus 3 squared and minus 4 over 1 minus 2x squared is less than 0 for all x is greater than 3. So that's the first point we need to make explicitly clear to the examiner, okay, so that we have shown that the fractional components are negative, okay. What we need to say then is, and this is why I wrote addition in when I converted them back into fractions, okay, we're then going to say that the derivative of fx is the sum of two negative numbers. Okay, probably numbers isn't the right word actually. Two negative fractions. Okay, because these can be algebraic and so on. Okay, so it's the sum of two negative fractions. Okay, so what this is saying is that we take one negative and we add it to another negative. Okay, and because of BIDMAS, the result will always be even more negative. You can't take one negative, add a negative, and get a positive, okay? It's always negative plus a negative is even more negative, okay? So we need to say now, therefore, fx is less than 0, okay? Because it is the sum of two negative functions, okay? And then from here we conclude and say this implies that fx is decreasing. Because remember, we said the characteristic of a decreasing function is that the derivative of the function is less than 0 for all x values. Okay, so that would conclude this question. So for this question, you get 3 marks. Okay, you get 2 marks for correctly differentiating your fx. Okay, so up until here gets us our first 2 marks. Your third mark, what you need to do is you need to explicitly show the examiner how you're getting to it becoming a decreasing function. So that means explicitly stating that x minus 3 squared and 1 minus 2x squared are both greater than 0, okay? And since the derivative of fx is the sum of two negative fractions, it means the derivative of fx is also always going to be less than 0, and using that to imply that fx is decreasing. So using the definition of a decreasing function and in relation to its derivative. So that gets us our third and final mark for this question.